Good evening, dear astronomers without borders. Tonight we speak to you from Rome, Italy, for this event of the Global Astronomy Month 2014. Welcome to our studio, where we will be presenting to you Aurora Borealis, an astro concert by myself, Stefano Giovanardi, and Angelina Yershovais, my musician and friend. We will be doing together a trip, a journey to discover the Northern Lights and their charm. Indeed, the story of this astro concert comes from a collaboration that is already going on since 2008 between me and Angelina, and we like to present to the public astronomical events and stories and phenomena, but in an artistic way, not only scientific. And in this particular case, we will be mixing astronomy as science, a travel reportage, and music, in particular electronic music and also acoustic music with the piano. Indeed, this version of Aurora Borealis is an acoustic version as opposed to when it began last year at the Planetarium of Rome, when the project was first presented in a more electronic fashion. Indeed, the setting for Aurora Borealis originally was the Planetarium of Rome, which sadly and shamefully has been closed and shut down just 2 months ago for an unlimited time, and we are actually very angry about this, and we should all fight for it to be reopened. But indeed, we want to bring you with us on an emotional journey towards the stars and the dances of the Northern Lights. Angelina will be the musician. She comes from Kazakhstan and is a musician and composer. She produced the soundtrack for this astro concert and other projects that we are working on. And I am one of the science curators and astronomers of the Planetarium of Rome. So we really hope you will enjoy traveling with us to Lapland to see the Northern Lights. It's actually high time to begin with our astro concert, so please follow us and enjoy Aurora Borealis. It was at least 10 years since I first dreamt of this trip. I had been struck once by the quick apparition of an aurora seen by chance from the window of an airplane at night. It is one of those events that seem to be magic, perhaps even supernatural, and instead it represents one of the most elegant displays of nature. All sorts of lores and legends are told about the Northern Lights, implying how much their apparition can change meaning in the eyes of those observing them. In Lapland, for instance, a popular belief explains the auroras as lights scattering from the tail of a fox jumping in the snow over the hills. They call them revontulet, the fires of the fox, or also vuotsahats, light that might be heard. I wanted to see the auroras again with my eyes. I was craving for finding it again along my journey, especially to live again that moment of enchantment, a spell that can suddenly reconnect you with the universe, to let you be one with the infinity. The apparition of an aurora is an event that flings wide the gates of mystery, carrying with itself a whistle, the whistle of a wind, Borea, the wind of the north, coming from afar. Thus, in early March last year, together with 13 other people, I chose Lapland to go chase the Northern Lights and discover their beautiful dance. Let's go. After 2 days of travel, we reached Ivalo, Lapland. 4,000 souls collected along the icy road toward Cape North, sliding gently across icy lakes and snowy trees. Here we are in the land of the Sami, the Lappish people friends with the reindeers. They are used to perpetual sunshine, as here the sun never sets from May 22nd to July 22nd. They are also used to perpetual darkness, the Arctic night. Because here the sun never rises from November 22nd to January 22nd. And it is the night that reserves the best surprises. In the sky, the North Star Polaris shines up to 69 degrees high above the horizon, 27 more degrees as opposed as seen to Italy. Instead, it is the sun that lingers low on the horizon. After all, we are standing far above the Arctic Circle. This is why the sun, climbing barely above the hills, ends up extending the shadows of the trees, of the people, and of the icicles. And white seems to be the color of everything until the night falls. Here is how the sun looked like while I was in Lapland from March 3 to 9 last year. A clean yellow disk with a few sunspots, even too few. We need to keep an eye on the sun because it is the main character of this story. It may sound strange, but what we were looking for at night depended on what was going on the sun by the day. So let's have a better look in the X-rays, showing the activity of the upper atmosphere of the sun taking place on those days. At higher energies, we can see the conditions of the external atmosphere of the sun, the corona. There were 3 large dark areas, openings of the external atmosphere of the sun, where the magnetic field escapes from the star and lets huge vents of matter flow away. The coronal holes. In fact, a huge amount of matter can escape the sun when the magnetic activity is suitable for that. The magnetic field loops over the sunspots, these dark areas, called their deeps in the solar surface. They are the true hubs of the solar activity. And the eruptions crackling above the sunspots produce flares, prominences, eruptions. And the amount of sunspots is crucial to keep high the solar activity. In fact, it follows a long cycle of over 11 years. The current solar cycle has just reached its maximum, and this is why this is a good time to go see the northern lights. Although the current cycle is the weakest of those that have been recorded so far, 24 of them. Nevertheless, above the sunspots, a huge amount of energy is released through those eruptions that can spit out in space enormous masses of particles, real clouds and bubbles of solar matter. They are the coronal mass ejections. And they are made of matter, electrons, protons, other ions. And altogether, they create the solar wind. A wind blowing away far and fast at speeds of 500, 1,000, even 300,000 kilometers per second. And such cascades of solar magma have a dreadful elegance. Yet, it is right there that the secret of the aurora is hidden. They depend on those tornadoes of fire, representing the climax of the infernal power of the sun. It seems unbelievable, but the icy arc of the northern lights originates in the hellish heat of the solar eruptions. here the blow of the solar wind springs up. As it flies away, we will try to follow it, because when huge bubbles of particles leave the sun, somebody very far away may be so lucky to find himself along their path, along their journey. And in fact, 2 days later, we were right there, waiting. Apparently, all this inferno seems to have nothing to do, seems to be completely unrelated to the beauty of the Northern Lights. Instead, what we will receive 2 days later will be the glancing blow of the solar wind to the Earth. It was damn cold out there, waiting for the aurora. At night, the temperature dropped down to 29 degrees below zero. And there we were, with our binoculars, cameras, tripods, all buckled up, trying to not to freeze up, wearing 2 pairs of gloves, 4 socks, and 5 layers of warm dresses to protect us from the Arctic night that does not forgive. Regardless of all this gear, the air would freeze inside our nose when breathing. After an hour outside, the cameras would fail. The flexible shooting wire became stiff and could not operate any longer. We didn't have other options other than seeking shelter inside in our cottage, using a hair dryer to defrost our cameras, taking a warm break before going out again, with a thermos of hot tea while waiting for the aurora. The wait was long, the cold sidereal. I was holding my breath as I reached the coldest temperatures of my entire life. Meanwhile, something was going on in space right above us. A quick stream of particles blown away by the sun was en route to the Earth, and it was due to arrive any time. We met in Lapland on an icy night of March, and when it arrived, this is what happened. It all had begun right there, on the sun, 2 days before. From one of many prominences arching over 2 sunspots, on the side facing the Earth, the lines of the solar magnetic field had twisted and locked on themselves, isolating a cloud of particles. Thus, 1,000 billion kilograms of solar matter flew out, as fast as 1,000 kilometers per second, spreading across the surrounding orbits. The show was ready to begin. But we still had to wait. All we needed to do was to lay along their trajectory. But planet Mercury came before us. When the cloud reached it, it could pass over the planet without meeting any resistance, and its journey proceeded on to the next planet, Venus. Again, the cloud passed Venus undisturbed, and it continued traveling fast to the following world that was reached after a flight of 24 hours, the Earth. And now the Earth opposes its own magnetic field to the arrival of the solar wind, defending and protecting us from the incoming particles. The fusion of the 2 magnetic fields of the cloud and of the Earth produces a surprising dance. The lines bend, join, and reconnect. Most of the particles slide away, deflected by the Earth's magnetic shield. But on the opposite side of the planet, when they seemed to have passed by it, they fall back into a trap. The magnetic lines reconnect, inverting the direction of the solar wind, now blowing back entire jets of particles. As they bounce towards the Earth, they enter the magnetic whirlwinds, moving along the magnetic lines towards the North and the South Pole, exactly where the aurorae occur. The solar particles, electrons mostly, rain down the atmosphere following the direction of the magnetic field lines in a swirling movement towards the poles. When they invest the upper atmosphere, they slam against the molecules and the atoms they meet, mostly oxygen and nitrogen. And in these collisions, they lose energies in favor of the oxygen and nitrogen elements that are suddenly excited to an upper level, from which they decay instantly to their original state, releasing the extra energy. Meanwhile, the electrons continue falling in a spiral movement towards the Earth, ever shrinking and losing energy to all the countless atoms that they meet in countless collisions. All these atoms and molecules release the energy they have accumulated with the beautiful light of the aurorae. And this is why the northern lights are so distinctly colored. Oxygen is responsible for the typical green tint of the aurora at an altitude of about 100 kilometers from the ground. Nitrogen produces the red glow at lower altitudes and occasionally blue stripes that extend far above. We may watch these cosmic cascades of solar wind falling down on the Earth from a remarkable vantage point, that of the astronauts aboard the International Space Station. From up there, flying high above the Earth, we can notice in the distance, surrounding the Arctic and Antarctic regions, the bright auroral oval encircling the poles. We even see the colorful pinnacles of the northern lights lift up almost to touch the International Space Station through the atmosphere. And especially, we can see these lights dance, change color and shape almost at their own pleasure. And here we are, for a moment, passing above Italy, so bright at night. And this is why this is not the right place to see the auroras. We live at a latitude too low to see them, and in the distance we can see the auroral oval up to the North Pole. We had to take 2 days and 2 airplanes to go up there to Finland. And in the same time, those solar particles were covering the distance of 150 million kilometers between the Sun and the Earth. We met in Lapland, and here it is finally what we have seen. Here they are, at last, my auroras. They appeared like that, mysteriously, without noises, without any advice. It was magic. One of those visions that literally raise you towards infinity. Every single image is the revelation of a universal wonder. Yet, if any of them could be enough to represent the enchantment of the heavens, the highest feeling of awe came by watching the auroras in motion. Because their behavior was different night after night, hour by hour, even minute by minute, we were mesmerized. It was impossible to look away, as if something wonderful and awesome was about to happen anytime. We saw a huge arc of green stretching across the entire horizon. We saw entire areas of the sky being illuminated, pulsating with green and red. We knew that this was physics, science. But at the same time, knowing and understanding the phenomenon allowed me to appreciate and adore it even more. The movements and the dances of the northern lights finally became the absolute metamorphosis of the universal wonder unfolding before us. I am not sure I really believe that those that I have seen were the fires of the fox, as the Sami say. I'm not even sure whether the northern lights actually make noises. Instead, I thought of the pencil drawings of a talented cosmic painter. Indeed, this is their pure meaning, the enchantment. At the end of those nights, when the dawn came with the twilight to bring back the sun, I closed my eyes. I was left with an astonished grin on my face, just a bit accelerated. Yet, I am sure that what I brought back with me from this trip is the neat sensation of having felt the blowing of a wind coming from as far as the sun, and of having felt once in a lifetime the breathing of the cosmos. Thank you to everybody of you following us from everywhere in the world. A special thank to Astronomers Without Borders for inviting us to contribute with this event to the Global Astronomy Month of this year. A special thank also to the Groovefarm studio and 12 Label who hosted us here and produced the event in Rome. You can see again a replica of this concert, Astro Concert, on the live stream channel that we have set up for you. If you have questions and comments, you're welcome to write them on the chat of the live stream channel. We will read and reply to you in the following days. Thank you very much and have a good Global Astronomy Month. Goodbye.